you're going to find K first. All right, so once again, you're given this input and output values. Okay, so you have a sample that decreases by 31% in 540 days. Okay, so you know what your output is going to be. Okay, but what you need to find, or what you need to apply, is this your sample decreasing by 31%. What that means is at the time associated with the 540 days, when you look at your output, so 540 is your input. When you look at your output, you don't know what your initial amount is yet, but you do know you're going to be left with what fraction of that. If it decreases by 31%, you're going to be left with what percent? So if you took 100 minus the 31%, right? So you're starting if you're going to decrease by 31%, it's 100 minus 31, or 69% here of that original. So when you set up your equation, it's going to be the decimal equivalent, 0.69, is equal to, now again, this is some initial amount. So it's 69% of that's going to remain. It starts with whatever that initial amount was, e to the k, and then our t value we said was 540. Okay, so this is the equation that you'd start with, okay, in order to identify what the new value would be based on a percent. Okay, if you divide both sides by a sub 0, whatever that happens to be, it cancels out of both. So the percent doesn't matter. Again, what the original amount isn't going to matter for this. You're just finding your k. And so once again, you do the same process. If your variable's in the power, you need to take the log or natural log of both sides. So if we take the natural log of both sides, here, taking the ln of both sides, we can move our 540k out front. The ln of e has a value of 1 when the input is equivalent to the base. And now we can solve for k by dividing both sides by 540. And this gives us our k value right here. Right. So when you are looking to solve this problem, what you're going to do is you're going to use the definition of half-life. Bless you. Bless you. And so this is the equation to calculate half-life. Okay, so in order to answer this question right here, what we're going to do is after we find our k value, we're going to calculate the half-life. And we'll use this equation right here. So the half-life is going to be negative ln of 2 divided by whatever our k value was. So here we got our k value to be ln of 0.69 over 540. And so when we calculate this, we get the answer to the first part of this question. All right, so I've entered a decimal in my, or I've included a decimal in my entry, so when I hit enter, I get my solution. So the half-life is 1008.72 years, or in this case, days approximately. Okay, so they gave you the units here. And then the final part here in this problem is how long to for a sample of 100 milligrams to decay to 52. And so now we go back in and we plug it into this equation. in the same manner that we would for as we did the last problem. So we're looking to take a sample that begins at 100 milligrams. So that's our initial amount times e to the k. Here's our k value is solved right here. So we have to the power of ln 0.69 over 540. T, we want to solve for t here. So there's our power. And we want this to decay to 52 milligrams, so that's going to be the amount at time t. And so once again, you can either use the solve feature of your calculator, or you can manually go through. Again, I'll write it here really quickly. So divide by 100, and then take the ln of both sides. The whole power comes out front, so ln of 0.69 over 540 times t, and then ln of e has a value of 1, and then you can divide both sides by this whole quantity. And those cancel, and that's going to give you your total time here. Now I'm going to go back in and I'm going to use the solve feature since I already did the other one by hand. So if I set this up using the solve feature, I get 52 is equal to 100 times e to the power of, and in my grouping symbols here, I have ln of 0.69 over 540 all times t. Close that off, and then I'm going to solve for t. I have my entry has a decimal, so my answer should display as a decimal. And when I enter this, I get 951.64 as my solution.